Allen Telescope Array, home to the SETI Institute, a group of scientists who've dedicated their careers to searching for extraterrestrial intelligence. And leading the search is Dr. Seth Shostak. How do these telescopes actually go about getting data for you?
In principle, all you do is you aim all these antennas in the direction of some star system that for one reason or another you think, you know, maybe it's just because it's a close star, or maybe it's a star known to have planets. You think that might be a habitat for ET, okay? And then you just search over a wide range of the radio dial, looking for a signal that's at one spot on the dial.
NASA's Kepler mission is now studying 150,000 stars, looking for planetary transits. How has that technique helped your search?
One of the problems we have is that, you know, we're aiming these antennas, as you can see, toward the south, on the assumption that whatever star we're aimed at has a signal coming our way that's arriving just at the right time, so, you know, it gets picked up. I mean, it's like two cowboys, you know, aiming their pistols at one another and having the bullets meet in the middle.
Across the vastness of the sky.
I mean, it's not very likely. But transits, the transit of the Earth in front of the sun, as seen by ET, gives them a clock. And they might be clever enough to say, wait, what we'll do is we'll broadcast a signal that gets to Earth just as it's transiting the sun, okay? And that way they'll know where to look when. So the bullets have a chance of meeting.
The chances of receiving a message from ET may be pretty slim, but by using the transit of planets, Seth and his team are increasing their chances of detecting a signal.
And what would the signal have to be like to get you out of bed at 3 o'clock in the morning?
Well, I don't think anybody would call me unless the signal had the characteristics required to get me out of bed. But it would have to be one of these very clean-looking signals, very narrow band, and drifting at some rate that looks like it's not a transmitter here on Earth. ET, yeah, I'll get out of bed.
Seth's pretty bullish about his chances of finding ET. And actually, I think he's got really good reason to think that way. Kepler and the science that's coming out of the planetary transits is really reviving and giving focus to his search. If I was new to science today, I would very much want to go into this area. There's so much data being collected about these planets, and we're learning so much about their size and their suitability for life. And I think that in the coming years, we will find what we're looking for.
Transits have been crucial in helping us track down Earth-like planets. But to find out if they sustain life, we need to take the next step. We need to get closer to these planets than ever before. Close enough to peer inside their atmospheres.
To get a peek at the atmospheres of these distant planets, I'm travelling as far out of our own atmosphere as I can get. This is a bit of a bumpy drive, but we're on the way to a really exciting place. We're going to Mauna Kea, one of the most famous observatories in the world. It's also very, very remote. I feel like I'm on top of the world, and I'm not far off. There's very little air up here compared with down on the ground. I can feel it's quite hard to breathe. All the weather, the turbulence down there, all of that is underneath, and that's why all these telescopes are here. So this is an amazing place to come, to get away from the Earth. It's like a step on the way to the sky. It's getting really cold here. The sun's just gone down. But the telescopes are waking up.
and there's this stunning sunset, and we can still just see all the telescope flaps opening. So as the view of the land fades away, the sky is opening up, and I can see Venus up there with my eyes. But beyond Venus are billions of planets we can't even see. And yet, using these telescopes, scientists have developed an exciting new technique to find planets with atmospheres that could support life. Now, all of these planets are just so far away, so many light years. How do you study an atmosphere that's that far away?
When they pass in front of the star, something very special happens. The light from the stars shines through the planet's atmosphere. And as it does so, the light is absorbed at different colors by molecules. And each molecule has a unique fingerprint.
What are the chemicals that you're looking for?
Well, the one that we're using as a key diagnostic right now is methane. Here on Earth, of course, methane is connected to life processes. We're really looking for life changing the atmosphere in a way which can't be explained by any other process.
So you collect this data using this enormous thing here. How does that work?
Well, this is the NASA Infrared Telescope Facility, a really marvelous telescope. And the instrument my team uses a lot is the SPECS instrument back here. This blue one works just like a prism. It breaks light apart into all these different colors, but mainly in the infrared.
I find the measurements that they're making here absolutely astonishing. The subtlety required to detect an atmosphere from this far away is just amazing. Science fiction writers have been inventing crazy planets for decades, and now we know they really exist. And it makes the sky, for me, a completely different place.
Studying the atmospheres of distant transiting planets is some of the most exciting science happening today. But precision is everything, and to be as accurate as possible, we need to know if we're doing things right. And that's exactly what David Ehrenreich does with one very special telescope 350 miles above us, Hubble. So what are you hoping to achieve from the Hubble observation of the transit?
We hope to retrieve the atmospheric signal from Venus. And to do that, we observe the transit of Venus with a spectrograph. So a spectrum looks something like this. So it basically tells you what's inside the atmosphere of the object you're studying. We hope that we will be able to, thanks to these templates, to distinguish between a habitable planet where life could possibly blossom and a non-habitable world.
So all of this is not just about analysing Venus's atmosphere, it's actually about looking for life.
That's the final goal, yes. That's the big picture, and this experiment is one step forward to achieve this goal.
Transits represent some of our greatest scientific achievements, and to me, they stand for our insatiable desire to constantly push the boundaries of our knowledge and to explore the unknown. Transits are some of the most beautiful spectacles in space. But they've also been crucial to unlocking the mysteries of our universe. And now they're being used to answer one of the biggest questions of them all. Are we alone?